science, but density is technically the amount of mass. Mass is your weight, just so you know. So right above that, put weight. So sometimes instead of using the word like, this is your mass, sometimes they'll say the weight is. Weight and mass are the same thing. That an object has in a single unit of volume. So sometimes this number will be really, really small, okay? The density of an object is found by, does anybody know the formula for density?
Mass over volume.
Beautiful, mass over volume. So we're gonna take, we're gonna divide. So we're dividing its mass by its volume. So this formula is not on your reference sheet. If you look everywhere on there, density is not mentioned at all. Density is mass divided by volume. The way I tell kids to remember this, and the way I even remember it, is literally it's like where you get your driver's license and you go to the DMV. So it's DMV. So mass is over volume, mass is at top, up top. So for the example, it says a standard brick has the dimensions shown below. If the mass of the brick, so the weight of the brick is 2, find the density. Well, that sounds easy peasy because we're just dividing numbers. So let's do it over here. So we have density equals mass over volume. How much is my mass?
2 kilograms.
2 kilograms over my volume. What's my volume? I don't know, but we know how to find it now. So we have to find volume first. So let's find volume over here. Now we have a couple shapes we can choose from for volume. This is not a sphere. Okay, we have a cone, we have a pyramid, we have a sphere, we have a cylinder, we have a prism. So which one is this? It's technically a prism. So if you look at your blue sheet, this is like chaotic. Take a second, it's overwhelming. This is like a lot to look at. Good. So your prism and your cylinder is big B times H. So volume equals big B H. Nope. Because big B is not little b. Little b is base. Big B is what?
Area.
Area of the base. So what shape would this base be if it's a brick? It's a square rectangle. Okay, so how do we find area of the base? Length times width. So what's the length and the width of just the base? 8 and then 3.675, which is a little weird, but whatever. So in a calculator, everybody pause, come get calculators. Hopefully eventually we get to the like coming up in the beginning of class. Like,
See, I was going to, but I didn't say
yeah,
that. So.
I know. I'm gonna forget to say it. So just come up in the beginning of class, grab the calculator for your table.
I do
My
too.
bad. Don't worry about the numbers on the back if you're ever putting them back. Just find an open spot and put it somewhere because like clearly we don't. Like match the numbers. Sure. Too much. Does everybody have a calculator? Does anybody need one? We're gonna use 675. We're not gonna round up. We're gonna keep it as 29.4. Is that what it says?
The last answer.
No. Okay. So for 29.4, now we're taking big B, we're plugging it back in. You should start to get you should be realizing that, oh, now I'm just going to multiply this number by the height. If you don't realize that, you can write it out. I'm taking big B, I'm plugging it in, 29.4. What's the height of the object? 2.25. Remember, I show every single step whenever I'm teaching. You do not need to show every single step, okay? So, but you do need to show work, okay? So times 2.25 times 2.25. So you get this. We are going to keep this. This is a nice number. There's really no need to round because we're not done with the problem yet. If this was the final answer like yesterday, then we could round. But like, we're not done. So let's just keep it because it's not super crazy. 66.15.
The answer I got is insane.
So yes, it is insane. So we are still finding density. Density equals mass divided by volume. Mass is 2. The volume is 66.15. So I'm dividing them and I get something crazy.
I have like 3 other.
So you get 0.03023, blah, 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 blah. If you think about this, because I know you guys conceptually don't understand much. Okay, we have a brick. Here's our brick. Okay. Our brick is this big. You can like easily kind of hold a brick in your hands, right? You're like, ha, 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 I got this. I'm strong. I can hold a brick because obviously it's not that much.
Yeah.
What this density actually means is this is the amount per cubic inch of your shape. So like, you know how like a 3D shape, I could technically make a bunch of mini cubes to fill this. You probably did that in elementary school to like fill in the space. So each one of those little cubes has that amount of weight. Nope. So our answer, our density is 0. We'll just say 0.03. So let's round to the nearest hundredth today because your numbers are going to be like, normally they're going to be smaller. So let's use 2 decimal places today. Because it's 0.30, we're going to keep it as 0.03. So let's do it again. Number 1. It says a section of a trunk of pine tree. So if you've ever gone out and tried to pick up a piece of a cut down tree, you're talking about a piece of a log, okay? Is that going to be light or is that going to be heavy?
Pretty heavy.
It's going to be super heavy. You guys has anybody tried to do that before? Like, yeah, it's not. It's not light. Unless your tree is very thin, okay, then it's light. But if it's a big tree trunk, it's going to be heavy. So our answer is going to be heavier. You have a question? What's up? So 2 is from the problem. The mass of the brick is 2. So I plugged it into the top of the formula. The top. Yeah. So a section of a tree trunk of a pine tree is a cylinder with the dimensions shown below. The mass, which is the weight of the trunk, weighs 531. So that's my M. That's my mass. Find the density once again. Okay. So density is equal to mass divided by volume. So what's going to be in the numerator of my formula over here? 531. Do I know the volume yet? No, but good thing Miss Alex taught me how to do that. So we're going to do it over here. So volume equals, now what shape is a tree trunk?
Cylinder.
The cylinder. So look at your blue sheet.
Big pipe.
It's big B times H.
We cut in half.
You will cut the radius or the diameter in half. So you got to find big B first off to the side. Okay, we are not using length times width because it's not a rectangle. What are you using? No, not based on height.
Radius.
Yeah, pi r squared. If you don't know that, that's okay because on your reference sheet, if you go to circle, because the base is a circle, it says the formula there. It's kind of just plugging formulas into other formulas. So a circle is pi r squared. So take a second, find the volume of your cylinder. You are not using 1. 1 is the whole this. What is your radius?
0.5.
0.5. Okay, 0.5 squared. 3 times it by 5. This is good. Okay, so now you gotta find radius. Yeah. Not 1. 1's the whole. Yeah. Yes. Yes. I know these numbers are ugly.
Which one should I like? How should I round it?
So I would round it to the near. So, well, you're not rounding yet because you're not done with the volume. So 0.5 squared times pi gives you this. If you want to write this down, you can, but remember, we're not clearing out the calculator. We should just leave it in the calculator. Okay. So I'm going to put 0.79 just there, but keep your calculator exactly the same. Now I have to take the base and what do I have to multiply by? 1.5 because I have to plug it back in to the actual formula. So 0.79 times the height. Hold on. If you realize that you either way you're multiplying by the height, don't write the step down. just in your calculator times by the height. You don't have to write everything down, okay? So you get 1.178. Why is it so like dark? Can you guys see my calculator?
No.
Okay, 1.178. So we're gonna say, because we're not done with the problem yet, let's write a couple decimals. Let's do like 1.1. You can write 78 if you want. I'm just gonna put 1.18.
Why not 7?
You could put 78, but because I'm rounding to the nearest hundredth, the 8 would go up. But if you want to put 178, that's technically more exact. The more decimals you use until you're done, the better off you are technically. Okay, so I'm gonna put that down here. 1.18. So mass divided by volume. So now you're gonna take your calculator, do 531, which is the mass. You're dividing by the volume, which you found. Because you want to. Was it nice? Like a nice number?
Always work.
1.18.
I think you did 1.18 divided by 531. 531 is the numerator, so that goes in the calculator first. Yeah, that's nice. Because did you use 1.178? That's fine. Which yours is technically more correct than mine. So like the more decimals you use, the better off you are, but it's okay.
No, it's not.
Okay, we'll see if we get that one.
Yeah, I got it.
Oh, okay.
I went small one.
Okay, how do we feel? It's like the third day of volume. What's up?
Like when you like do the problem, do you like how to do it like?
Isn't that what I'm doing?
Yeah, I feel like when we work on bio.
Oh, when you're working, like show the steps up here. Yeah, like I'll flip the paper back. Yes. Okay, let's go to number 2. Number 2, same thing. Okay, a ceramic paperweight has a dimension shown below. If the mass, which is the weight, the mass of the paperweight is 8.4, that's my M. I need to find density. So let's set up our little density problem off to the side. Density equals 8.4 over a mystery number, which I need to find, which is the volume. So take a second, look at your blue sheet, try to figure out what formula you're going to need for this. Don't say it out loud. Do give people a chance to think. Okay. Try to find your formula, try to find your shape. Yes. I think, okay, what you did is you typed in 1.18 divided by 553. Clear it out real quick.
Yeah.
Yep, put 553 first,
Regular.
divide by this. They gave you something weird again? Okay, there you go. So I think last time, yeah, I think last time you put it there.
Oh, yeah.
Okay, so what's my volume formula for this shape? 1/3 big B H, okay? It's 1/3 because it comes to a point. That's technically why, but you don't need to know that. It's on the formula sheet anyways, but if you're curious. So big B, try to find big B. Big B is a square. No, oh yeah, but not yet. So find big B. I'm doing like a head C. Big B is a square, so you're doing length times width. Since it's a square, use the same number twice. 3, yep.
One side of it.
For length times width. Yep, 9, because we're doing 3 times 3, which is 9. Okay. Nope. So big B is 9. And then we run into a problem. This is the only problem that we have this problem. Okay. The ones on the back, you do not have to do this at all. But if I look at what's given, I have the slant height. I need the vertical height straight down to the center of this. So we're going to do the Pythagorean theorem to find the actual missing height of the shape. So I'm going to use this open space over here to make my triangle. This is the only problem on this entire paper that has this. So for the right triangle, what's the hypotenuse? 2.5. I don't know the height, so that's just h. What's the bottom? 1.5. The reason why is because if the whole length is 3, it would be half because it's going from the center to the side. So take a second. We're going to do the Pythagorean theorem. We have h to the power of 2 plus 1.5 to the power of 2 equals 2.5 to the power of 2. If you know how to do this in the calculator without showing the work to the Pythagorean theorem, I'm fine with that. It's okay. If you want to write it out, that's also okay. Can you condense? Yes. And this height comes out to be a very nice number. It's not a best bet.
Bye, guys.
It's a 6.
I'm not wrong.
6 or 2? I think it's 2. Oh wait, what is it? That's 2. 2, not 6.
I was talking about the last.
Oh, that's what I was thinking.
You have to square.
Remember, if you get 4 for the Pythagorean theorem, I think I showed this to you yesterday also. You can cheat the system with the Pythagorean theorem. Did I show you this yesterday? You can just plug it into the calculator. If you conceptually, which there's only a few of you, understand what you're doing, if you take 2.5 squared, shh, be quiet. You're squaring that. You have to minus this. So I'm going to minus 1.5 squared. You get 4. And if you conceptually know that at the end, you're going to have to square root it, shift square root at the end, poof, you get 2. So your height ends up being 2. Okay. So your height is 2. And now I just multiply these together. 2 times 9. Don't forget about your 1/3. So what do we get? We get 6 for the volume. So now you can divide your mass by your volume to find the density per cubic inch. Was it 1.4? It's a little different.
It takes a lot of time.
Okay. So start number 3 by finding the volume of the cone. So just find volume because you know you're gonna have to find volume, and then we'll talk about the word in the problem. Start by finding volume of cone. Yeah, leave your. Yeah, just go next. Leave your phone. No, so 2.2 is the radius. The whole thing would be 4.4, but there's no point in doubling it and then cutting it in half. So you're using 2.2.
Wait, no, no.
So we don't do anything when we get there.
So like that's gonna be r squared. Or 50, pi r squared. Because the base is circle. Yeah, you're using pi r squared for your circle. For number 3, because of the circle, pi r squared, your r is 2.2. You don't have to split 2.2 in half because it's already a half, because then if you split it in half, you have 4, and you don't get a 4 and a half. You don't have to use for that. What are you confused about?
I got
Are you confused why you're using 2.2?
I did.
Yeah, correct. Yeah, that's correct.
Oh, I mean, it's constant.
Oh, no, I don't want now.
Well, no, you gotta finish the problem. But we're gonna talk about it in a second because it's different from the other ones.
Exactly.
Yes.
How does that 7.5? And,
That's a big piece.
I got one.
Okay.
I would get But I do have this.
I got, I got for no.
No, we're not doing
Very lucky. Good job.
And then the math. Oh, wait, one number. So you have.
So what is big B?
Oh, I mean. 15.2.
15.2, but keep it in your calculator. You're gonna plug this in. 1/3, 15.2. What's the height? 7.5. So in the calculator, you're not clearing your calculator, remember? So I have 15.2, blah, 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 blah. I'm gonna times it by 7.5. Times by 1/3, you get like 38.01, whatever. Now if we go back and we read the problem, that is the volume. Okay, so volume is this. It says the plastic used to make a solid cone has a density of 0.95. So this time I know the density, grams per cubic centimeter. Find the mass. So this time I'm looking for M. I know density. Hold on. So density equals mass divided by volume. So what should I do? Yes, because I'm going to plug in 0.95 here to density. I'm trying to find the mass. The volume goes in the denominator this time because, well, it always does. Now, usually you're just dividing the numbers, but in 6th grade, you should have learned about single step equations. The opposite of division, a fraction is fancy division. The opposite of division is multiplication. So to get rid of the denominator, I am multiplying by that to both sides. So I'm going to multiply by 38.01. They cross out over here. And then I multiply by 38 point. Do we remember this in middle school?
Yeah.
Single step equations. It was a long time ago. You're multiplying because it's the opposite of division. So normally you have the numerator and denominator, so you can just divide them. But this time I'm trying to find the mass.
So it's 0.95 times 38.
Yes. So it's around 36.1.
36.8. Sit down.
How do we feel? Okay. If you're a decimal slightly off, it's okay. It's okay. As long as you got 38 point, or wait, you got 38? You got 38.1 for the volume. Now you have to multiply it by 0.95.
Wait, we just leave it like that whenever we get the mass?
Yeah.
Oh.
Because the density is given to you instead of asking for the density. So if it says find the mass or find the weight, that's when it's multiplying instead of.
You can come down.
Yeah.
So instead of dividing.
But we not get up if I never see those.
Get rid of this denominator.
Yeah.
And just bring it in dividing. Oh, I thought you meant like. Now we're gonna go. Where you going? It's one of the just outline you what's.
So.
Okay. On the back. Yeah, leave it up here. On the back, there are 4 questions, none of which use the Pythagorean theorem. Okay. So that's your assignment for today. When you're done with this, you are turning it into Canvas. You are not turning it in because this is a notes paper. So you're only taking a picture of the back because that's the actual assignment. The front is the notes, the back is the assignment. There's no point in you taking a picture of the front. You get credit for your notes. Shh. You get credit for your notes when you do a binder check, which you will have before the end of the 9 weeks. I basically do one binder check before the end of each 9 weeks. So speaking of binders really quick, let me explain to you how your binders are going to be organized. So polish